Today's session is on different types of optical fibers. So, different types of optical fibers are step index fiber and graded index fibers. These are used in communication purpose, and this classification, this step index fiber and graded index fiber, this classification is based on the refractive index profile of the core. Refractive index of core means we know the structure of optical fibers. The center portion of the optical fiber is called core, and the outer covering is called cladding. So light is propagated through the optical fiber by total internal reflection. So for occurring total internal reflection, the core must be a denser medium. That means refractive index of core is always greater than the refractive index of cladding. So, based on the refractive index profile of core, we can classify optical fibers into two categories: step index fiber and graded index fiber. So, in step index fiber, the refractive index of core is always constant. But in graded index fiber, the refractive index of core is not constant and it is varying. So, we can go to the first category, step index fiber. In step index fiber, the refractive index of core is maximum. Core is maximum means we know the structure of optical fiber. Center portion is core, outer covering is called cladding, and this core and cladding is protected by another protective layer, and this protective layer is covered with another protection. So here the refractive index is gradually decreasing. That means a stepwise decreasing of refractive index from core to the outer covering. That means refractive index of core has maximum value, then cladding, it is less than the refractive index of core. Then consider the outer covering. For outer covering, refractive index is less than on this cladding. So a stepwise decrease of refractive index from the center to the outer covering. So refractive index of core has maximum value and is constant throughout the core. Constant throughout the core means here the light get reflected by total internal reflection. It is propagated from one point to the other point. So every point light get reflected from the core cladding interface of the core, from the top surface, then from the bottom surface, again from the top core cladding interface, then from the bottom core cladding interface. So light get reflected continuously by total internal reflection. For this, refractive index of core must be a constant. So in the first point, refractive index of core is maximum and constant throughout the core. Second point is there is a stepwise decrease of refractive index in the cladding that we explained in the first case. Then the refractive index of cladding is represented by the mathematical equation n2 equal to n1 into 1 minus delta. n1 is the refractive index of core and delta is the relative difference of refractive index of core and cladding. Then n2 is the refractive index of cladding. So refractive index of cladding is related to refractive index of core by this equation. This is step index fiber. Then step index fiber is further classified into two: single mode step index fiber and multi-mode step index fiber. This is the another classification of optical fibers based on the mode of propagation: single mode, multi-mode. So mode of propagation means the number of light waves that can be propagated at a time. That is the mode of propagation. So we know that here we propagate data or image or voice notes in the form of light waves. We know that light is an electromagnetic wave. Or in other ways, this mode of propagation means the number of electromagnetic field present inside the optical fiber. We know that light is an electromagnetic wave. So the mode of propagation means how many electromagnetic fields that can be allowed at a time. That is the mode of propagation. So based on the mode of propagation, we can classify optical fibers into two categories: single mode fibers and multi-mode fibers. So from the name itself, we can clear the concept. Single mode means only one light can be propagated at a time. Multi-mode means number of light waves can be propagated at a time. That is the multi-mode. So in the case of step index fibers, step index means refractive index of core is uniform. The step index fibers are of two types: single mode step index fiber and multi-mode step index fiber. So from the name itself, we can explain the concept. Single mode means only one light wave. Step index means refractive index of core is uniform. So only one light wave can be propagated at a time. So you observe this diagram. Look at this diagram. Here only one light wave is propagated through the core. The center portion is core and outer covering is called cladding. Only one light wave is propagated at a time. The second point is its core diameter is very small because only one light wave is propagated. So the cross section area for one light wave, it is very less. So here the diameter of core is very small. It has low attenuation and very high bandwidth for this single mode step index fiber, and it has low numerical aperture. Numerical aperture means light gathering capacity of an optical fiber. So here the cross section area is very less, so less amount of light can be gathered or collected through the core. That means only one line or a single light wave is propagated, and this is used for long range communication or long distance communication. And this diagram represents the refractive index profile of step index single mode fiber. Consider this as an axis. So this axis represents the refractive index mode. So here this point has the maximum refractive index, and here the diagram is a straight line. So this straight line represents a refractive index of core is uniform and it has the maximum value. This line, this is the maximum value. So here core has the maximum value. This core has the maximum value, and this point, this line, second straight line second region represent refractive index of cladding. Here also it is a straight line. So straight line means refractive index of cladding is also constant. Third one represent the refractive index of outer covering. So here it is also a constant. So this is the refractive index profile of single mode fibers. Single mode step index fibers. The outer straight line represent refractive index of core. It is straight line, so the refractive index of constant. If this line is not spherical, then we can say that refractive index is constant. Here the second line, this is also straight line, so this represent refractive index of cladding. This is also constant. And here the refractive index of cladding is this much value, so this is less than this value. So here core has maximum value, cladding has less value compared to core. This is step index single mode fiber. Then goes to step index multi mode fiber. The only difference between step index single mode and multi mode is large number of light waves can be propagated at a time. So here the difference between refractive index of core and cladding is small, because a large number of the refractive index of core, that means refractive index of this region minus refractive index of this region, this has a large value, means here large number of light wave is propagated at a time. Then its core has large diameter, it is clear. So here a large amount of light is propagated, so this size is large compared to single mode fibers. It is used in short range communication, means short distance local area networks. We used step index multi-mode fiber, and this diagram represents the step index refractive index profile of multi-mode fibers. Here compared to single mode, this has a large value because core, the size of core is compared to large here. If we consider the size of single mode fiber, the size of core is comparatively big. Then this is a straight line, so refractive index of core is uniform. Then this has the maximum value. Then this second line represent the refractive index of cladding, so refractive index of cladding is also constant. Third one represent the refractive index of outer covering, it is also constant. So this is the profile of step index multimode fiber. Then goes to the second classification based on the refractive index profile, that is graded index fiber. Graded index fiber, the refractive index of core varies parabolically such that its maximum at the core axis and minimum at the core cladding boundary or core cladding interface, that we can observe through the diagram. So this is a graded index fiber, this is the core and this is cladding. This axis represent the axis of the core. Light is propagated through this region. So at this axis and near to this axis, refractive index is maximum, and the refractive index is found to be decreasing from the center to the core cladding interface. That means a radial decrease of refractive index from the center to the core cladding interface. That is, refractive index is decreasing from the center to the core cladding interface. This is graded index fiber. Then here graded index fibers are multimode fibers. That means a large number of light waves can be propagated at a time. This curved lines represent refractive index is not constant, and near to the core axis light is propagated with maximum intensity, and near to the core cladding interface the quality of light wave is very poor because the refractive index of core is very small at this point, at this region compared to the axis, and this represents the refractive index profile of graded index fiber. Here the first line, this is not a straight line, this is a curved line, and the axis, the point at the axis, this represents the maximum value of refractive index, and the line is like this. So from the axis to the core cladding interface, refractive index is found to be decreasing. So here refractive index is not constant, and the refractive index is maximum at the axis, and it is radially decreasing from the axis to the core cladding interface. The second one is straight line, and this region represents refractive index of cladding, and this much difference is there from core and cladding, this much difference. And this is the refractive index of cladding, this is also constant. This is the refractive index of outer covering, this is also constant. So this is the refractive index profile of core cladding, graded index fiber. So optical fibers are generally classified on the basis of the refractive index of core and mode of propagation. Based on the refractive index of core, there are two types: step index fibers and graded index fibers. Based on the mode of propagation, two categories: single mode fibers and multi-mode fibers. Step index fibers are single mode and multi-mode, but graded index fibers are always single mode in nature. So we can compare the three types of fibers. This is graded index fiber, this is step index single mode, this is step index multi-mode. So in step index multi-mode, a large number of light wave is propagated through the core. This dark region represents the core. A large number of light waves can be propagated. Here only one light wave is propagated, that is step index single mode. Here large number is propagated, but the refractive index of core is not constant, that is through the axis this core we can observe a dark region near the axis, but that darkness is decreasing, means the intensity of light wave or low quality light wave is transmitted near to this core cladding interface. So this is the profile of refractive index profile of three fibers. We can observe here the size of core is high compared to the size of core of step index single mode fibers. Here only one light wave is propagated. Here large number of light waves can be propagated. So size is high and refractive index is constant in single mode step index fiber and multi-mode step index fiber. And the second line represent the refractive index of cladding. Here also it is constant, here also it is constant. The third one, here the refractive index, this region represent refractive index of core. At this point refractive index is maximum. From this point to this region refractive index is found to be decreasing. If the line is like this, refractive index is, we can say that refractive index is constant, but here the refractive index is radially decreasing from the center to the outer covering. Then second one is straight line, so this represent refractive index of cladding is constant. This is the classification of optical fibers. Thank you.